What is up, everybody? Today, we are back in Universe Sandbox, and we're going to be doing things that you guys suggested because it has been a long time since we've pulled those from comments, and you guys keep leaving a ton of comments. We're starting with this suggestion here, which says, make every planet, including the sun, double in size and see what happens. Double in size. Does that mean do we change the radius or the mass? Double in size means radius. This is gonna completely destroy the system though. The sun's twice as big, the mass is almost 8 times. So it's really gonna pull stuff in. So radius here is 0.38, so 0.76 of Earth. That's math, right? Venus is 95% of Earth, so we're just gonna do about 2 Earths. And then for Earth, obviously, let's actually see. I wonder, because Earth might actually have a big difference with the life on it. The radius, 1 Earth, 2 Earth. And the simulation's paused right now, so we're gonna have to see what happens when all of these are unpaused and going. 0.53, 1.06. I better not mess anything up, you guys are gonna bully me. 1 Jupiter, make that 2 Jupiters. I wonder how big Jupiter has to be to become a gas giant. So the thing is, we're doubling all of their radiuses. Their radii, I think, is the correct term. Anyway, their mass is becoming a lot bigger. So if everything is way more massive than it started, this is gonna be interesting to see. Okay, there's Saturn I actually want Saturn's rings on. So if we add the normal Saturn ring, it's like absorbing it now. Uranus, about 4, so let's do 8. And then Neptune is, let's do 7.8. Around there. Okay, we're gonna want to slow down time to see the changes very slowly. I want to watch Earth because I have a feeling our atmosphere might like completely leave. Actually, Earth's looking pretty good. What's our life likelihood? Okay, it dropped all the way to 26. It's like 90 something usually. And then let's see Saturn too, because we added the rings. So I assume all the ring particles are gonna be hitting it. Whoa, that's pretty stable actually. Okay, so it looks like not that big of a deal for most of the planets. What is gonna be a big deal though is what happens with the orbits. See, because the sun especially went from 1 mass of the sun to 8. So the sun is 8 times more massive, which is gonna pull on the planets a lot more. You can already see Mercury getting pulled in. Is anything gonna get sucked up? It doesn't look like it, but we're gonna get these very elliptical orbits as everything starts swinging around the sun. That is interesting. So I don't think Earth is gonna like this one bit. Look how bright that is. Let's turn off the space goggles. Blinding. Look at Earth. It's so bright, the ground on Earth would blind you. Life likelihood is 13, and then it starts to go back up. Okay, now it's 4. After a few more times, I'm assuming it's gonna be 0.6% chance of life. We still have a chance. That's me. The 0.3% chance is because I would survive this. Okay, next suggestion. Can you collide all the planets in our solar system and then collide that with J1407b and its rings? Okay, that's an interesting one. So J1407b is, at least it used to be considered the planet with the largest rings. There's some new info on that. I have a whole video about it if you want to learn more about it. So click the iCard or whatever. But we're still gonna do this, assuming that it is a planet. So we're gonna start by colliding all of the planets. So here's Mercury, and then we'll put Venus next to that. And there it goes, they combine. And then Earth, Mars, and Jupiter is gonna just eat all of this. Yep. It's really just gonna be Jupiter with some extra stuff in it. Okay, there's Saturn. And they collide. Just a giant lava ball. Okay, Uranus. And then finally, Neptune. And that is it. There are no more planets. So don't even say Pluto. We'll give it some time to kind of absorb all of the debris. And it does just look like Jupiter. So now we need to get J1407b. We're gonna start with a random gas giant here. Once again, watch the video. A lot of this, we're just assuming it's still a planet. 10 to 40 times the mass of Jupiter. So I don't know, let's go in the middle of that, 20. And yeah, it's starting to become a brown dwarf. And then the ring system goes out 90 million kilometers. So let's get a, I don't know, realistic ring, but we're going to, why is the planet called Nose? This is so laggy. Are we even gonna, there's so much lag. Okay. We're gonna have to do less ring particles. No, it's gonna miss. It's gonna miss. Quick, change the, velocity. Aim at this. Is that, oh, that's not even on it. Let's see them collide. It's actually bigger than our 20 Jupiter thing. Whoa! Okay, what is happening? Is it absorbing it? And it's lighting up the rings? Are these gonna like melt? Temperature? No, I don't know if it simulates temperature on ring particles. But there they are slowly combining into, I'm assuming, yeah, our Mega Jupiter beat it. Even though the mass was higher on J1407b. Okay, let's see what happens to the rings now. So this velocity is gonna carry through, and they're kind of like twirling up, following it. They're trying to stay in orbit. This is as fast as the sim will run. That does look cool though. The ring's like swirling up past it. Just imagine it would be, you need the most powerful computer to ever exist, but with all of the ring particles, like simulating a ton more, because this is very, very limited in what my computer can do. That does look super cool though, as it swirls up and around. That was a good suggestion. Let's go to the next one. Stop. Before we continue, did you know that your data may be exposed online? There are hundreds of data broker websites out there, and they've got tons of your sensitive data, like your name, phone number, emails, and even your address. That's where today's sponsor, Incogni, comes in. Incogni is a service that goes out and automatically forces these companies to delete your data. You don't have to fill out any forms or send any emails, they do it all for you. They just recently added a custom data removal feature too, which is really cool. So if you're ever on the internet and you find something about yourself online that you don't want out there, just tell Incogni and they'll remove it for you. I've been using Incogni and it's really helped me stop worrying about my data. I didn't even realize how exposed I was until Incogni comes back and says that they've deleted my data from dozens of different websites. If you value your privacy, check out Incogni by clicking the link in the description or going to incogni.com/spacechip. By entering code SPACECHIP at checkout, you'll get 60% off an annual plan. And there's no need to worry because Incogni offers a 30-day money-back guarantee. Thank you to Incogni for sponsoring this video. Let's get back to it. Our next suggestion says we should swap the Earth and the Sun, like their placement, but make the Earth have the same mass as the Sun and the Sun have the same mass as the Earth. Okay, that's actually really interesting. Replace with Earth, but the mass of Earth should be the same as the Sun? I think it's just gonna turn into a star because a planet can't be that big. Replace the Earth with the Sun, but we want the mass to be one Earth. Where did it go? It disappeared. Okay, I think we have to slowly decrease it. So let's just start with this because I assume this is just gonna turn into a star. Like what, a dark star? It says star. So the mass is correct. Is it gonna start heating up over time? Okay, it's like a dark star. What? 287 Kelvin is only 13 C, and it is holding the solar system together. Huh. Okay, we'll check back in on that. How do we add the sun without it dying? Okay, let's try orbit the sun at 1 AU. That's how far Earth is. Can we slowly bring the mass down till it's 1 Earth? Okay, shrinking. Yes. All right, the mass is now 1 Earth. Let's see what happens when we play on this. So the Earth turned into a dark star. I wonder if the sun's gonna turn into a bright planet. Oh, wait, hold up. Turn the flashlight on. Okay, it turned into a gas giant, which I guess makes sense because the sun's made of hydrogen, but it looks like it's ejecting something, or it's just kind of like figuring out how to be a planet. It's gonna fly into, oh no, it's in orbit. Perfect. There's the sun as a planet. I guess that's what the sun looks like on the inside. That's not real. Don't quote me on that. But there's the sun in Earth spot shrunk down with Earth in the sunspot, but scaled up. Why does it look like this? I'm actually confused. I just don't think the game can really handle this. But there you go. Let's go to the next one. This one just says, why do you hate Pluto? We'll go to the next one. Our next real one says, make every moon in the solar system part of Jupiter's ring. Okay, so here's Jupiter, right? If you didn't know, Jupiter does have a ring. It's just very dim, especially compared to like Saturn's rings. So we're gonna add that. There we go. So these are all of, I don't even think it's all of them. Maybe it is. These are Jupiter's moons. So now we wanna go in and add, how can we add, hey, this might work. What if we rename it to Saturn and then click add moons again? Is it gonna add Saturn's moons? Wait, did it? Oh no, it added Jupiter's moons again. Okay, it did say every moon, so we added those again. Anyway, the moon obviously deserves front and center. Phobos and Deimos are Mars's moons. Io's already here. We need Enceladus, right? That's from Saturn. Wait, now I'm forgetting what moons are from what planet. We're just gonna add all of these. There's a ton of minor moons that I don't think we can add, but let's turn on the orbit lines and see all of these. Whoa. Okay, look how many moons Jupiter, it's not actually Saturn. If you forgot, this isn't Saturn. Look how many moons it has. I wonder what planets can we add and keep this. Mercury's the size of a large moon, so that should be fine. What if we throw Venus in here and Earth in here and Mars in here? As soon as we add a gas giant, the whole thing's gonna go crazy because those are gonna be massive enough to actually pull Jupiter. Let's see if this is stable. Whoa, it's definitely not what just died. I don't know, Earth's getting hit. Earth is dying. The fragments are hitting Earth. What's our life likelihood? 8, it's not 0. Once again, it's me. I'm the one person that's alive, keeping this above 0. And to end this off, let's try adding a gas giant. What's the smallest one? I think it's Uranus, right? So what if we just throw this in here and pretended that was a moon? Is that massive enough to destroy this system? I think it probably is. Yes, definitely. Look at all the orbit lines shaking. And they're shrinking. Jupiter and Uranus are gonna be in sort of a binary orbit. But what does that do to all these moons? Not good things, it looks like. Let's just add Saturn and see what happens. That's got to destroy something. That's got to ruin all of this. Whoa. Okay, it looks like it ejected the moon. So these lines are showing an object's orbit. And so when they were around Jupiter, they were all like circularized around Jupiter. But it looks like Saturn kicked a lot of the moons out. And instead of orbiting Jupiter, they're just going around the sun. And it's picked up some of the moons. There you go. There's a very complex orbit thing. Let's go to the next suggestion. Our last suggestion for today says that we should make life on Mercury. So we're gonna terraform Mercury, Mercury is gonna be hard to terraform. Look how close it is to the sun. That may not look like that close until you turn on the habitable zones of the star. So if you're in the green, you're good. Venus has a super thick atmosphere, for example. So for Venus to have a good temperature, it actually have to be all the way out here. Mercury's in the red, which means it's gonna be very hard to get a good temperature on here, but we're gonna try. So the first step to terraforming a planet, we're gonna want an atmosphere. Previously in this game, you had to add a little bit of hydrogen to get an atmosphere to stick to a planet. What if we just try to throw Earth's atmosphere on here? Okay, that looks pretty good. Now we need to add some water. So we could just adjust the sea level thing and bring some, it's all evaporating, I think. How do you cool a planet down that's so close to its star? I think rotating faster would be good, because if it rotates too slow, one side is going to get too hot. So by making its rotational period a day, that should help. Greenhouse effect is at 186. Number of atmosphere layers, make that 1. Okay, that lowers our greenhouse effect. This is how much the atmosphere is heating up the planet. So by making it 0, we're not getting any hotter from the atmosphere. So that should help with our life likelihood, right? 0.6. Okay, let's see if we can get it above 5%. Hypothetically, like how much of this is just temperature? If we make it 15 degrees, that looks a ton better, and we're at 16% chance of life. The problem is, that's not gonna hold. Oh, I know. Planetscaping? Ice. Just cover the whole thing in ice, and then it should be fine for like a few hundred years, right? Does this change the temperature or no? It should. Universe sandbox, why does this not change the temperature? All right, we'll just cover it in ice and the ice will melt and then the colonists will have water. Let's also make sure that the vegetation is on there. Yeah. Okay, here's our terraformed Mercury-ish. Good luck trying to live here. We do have a pretty solid 18% chance of life. And it's going up. You see that? It's going up. So as far as I know, this could run forever and never get too hot and melt. Thanks for watching. Put your suggestions in the comments. Goodbye.